we're given an equation that's written in polar form, and the equation for the curve given, and they have a picture of it for us there, is given by 1 minus cosine 2 theta, which is ultimately a spiral shape, or at least half of that could be a limacon. But bottom line is, with this equation, they tell us that we're going from 0 to pi. They have a graph from 0 to pi, and then S is the shaded region, the part that's in the third quadrant, if you will. And then part A here, it just says write an integral expression for the area of S. Okay? So notice they didn't say find the area. They didn't ask us to anti-differentiate anything. We just wanted to find the area. So ultimately, if we do our integral in general, we know is an integral is 1/2 of the r squared, r being the 1 minus 2 cosine theta in this case, d theta. And then the key issue that we have to look at here is what about the limits here? So if you look at the curve given, again it starts at 0, and we can see that the shaded region starts at 0. And I guess our biggest issue is what's the upper limit here? What is that point in terms of theta right there? Well, keep in mind that this being our cosine theta, the question is what value of theta would give us 0? Well, we'd need ultimately this 2 cosine theta to equal 1. So that means that the cosine theta would have to equal 1/2. True. And so that's how we get that theta value there. It would be pi over 3 where cosine equals 1/2. Okay. So therefore pi over 3 would be our correct limits. And then the point breakdown for that was 2. If you had the correct limits and the constant, 1 point for that, and then the correct integral, which is the r value squared. So every time we're looking for the area with a polar curve, our general formula is going to be the integral 1/2 times the integral from a to b of r squared d theta, and that would do it. And again, they didn't ask us to evaluate it or anything. We just had to write it and be done. All right. Next question on part B says write expressions for dx d theta and dy d theta in terms of theta. And ultimately, if we're going to write something dx d theta, the derivative of x with theta as the independent variable, okay, if we're going to find the derivative of such an equation, we need to have an equation like that first. So with that said, we know that x equals r cosine theta and y equals r sine theta. Which is true for any polar curve. The relationship between x and theta and r is as such. And so in our case, we can't find dx d theta right now because we have this r here, but what do we know about r? R is equal to 1 minus 2 cosine theta. So that means that x is equal to 1 minus 2 cosine theta times cosine theta. In same fashion, y would be 1 minus 2 cosine theta sine theta. Right? And we can simplify those if we want to. Bottom line here is that we need to take the derivatives here as with respect to theta. So we want dx d theta here and dy d theta. So dx d theta in our case, we'd have to use the product rule here for our expression in theta. So we'd have 1 minus 2 cosine theta times negative sine theta. And then we go plus cosine theta times the derivative of this would be 2 sine theta. Alright. And with that, we would have, we could go negative sine theta minus 2 cosine theta sine theta. And here we have plus 2 cosine theta sine theta. Nope, this is a plus. Plus that one. Minus minus. And if I put those two together, those two are like terms, so we'd have 4 sine theta cosine theta minus sine theta. That would be my dx d theta. 1 point for doing this, 1 point for recognizing that you can write an equation for x and y using the r cosine theta and r sine theta. Um, and what else? Oh, yeah, that's okay. Good. Actually, yeah, they did it slightly different than I did in terms of their point breakdown. If you did it like I did, you'd ultimately get 2 points for all that. One point for each of these parts, I guess. So, and the dy d theta then would be again 1 minus 2 cosine theta times cosine theta plus sine theta times 2 sine theta. Ultimately give us 1 minus 2 cosine squared theta plus 2 sine squared theta. Alright. And that would do it, huh? Alright. Questions on that one? Oops, I missed one. There it is. Cosine theta. Distribute that. So, 4 points total for that whole problem. You got 2 more for getting the 2 results. So 6 so far. Questions on part B? Okay. Part C asks us to write an equation in terms of x and y for the line tangent to the graph of the polar curve at theta equals pi over 2. So keep in mind that if we're going to write the equation for the tangent line, we're going to need the slope of the curve at the point in question. And so we ultimately need dy dx, find the slope for the line that we're about to write. So what do we know about dy dx? What would it be equal to in terms of what we've already found? To be dy d theta over dx d theta. So that means we'd have cosine theta minus 2 cosine squared theta plus 2 sine squared theta on top. Bottom, before sine theta cosine theta minus sine theta. And we want the derivative at pi over 2, it says. Well, pi over 2, we'd have 0 here, 0 here. That would all be 0. So bottom line would just be this right here. So we'd have sine of pi over 2, that's 1, squared is 1, times 2 is 2. Pi over 2 in here would give us 1 also, but we got a negative sign, so it would be negative 1, so it'd be negative 2. So there's your slope. Alright, and the other question then is if we're going to write an equation for the line tangent to our curve here. Essentially need to fill in the other 2 blanks. Got that blank filled in, but we need to figure out what about y and x. Ultimately, up here, don't we have 2 expressions that relate x and theta and y and theta? So if we put our pi over 2 in here, we're going to get 0 here and 0 here. So ultimately our x is going to be 0. And in this one, if we put a pi over 2 in there, we're going to get 0 here, 1 here. It'll be 1 times 1, y minus 1. The final answer then will be y minus 1 equals negative 2x. And point breakdown for that part, part C, was finding the x and y values, finding the negative 1 and 0. You got a point for doing that. Point for getting the slope correct, and a point for writing the correct equation. Questions on that one? got here with number 5 then. Right. Number 5, we have a graph of a derivative. And it tells us that f is a twice differentiable function on the interval negative 1.2 to 3.2. F of 1 is equal to 2. The graph of f is shown above. The graph of f prime crosses the x-axis at negative 1 and 3. Has a horizontal tangent at 2. And our g is defined by e to the f of x. Okay. Alright, so let's see what we can do here. We need in part A, it says here to write an equation for the line tangent to the graph of g at x equals 1. So the g function again is e to the f of x. Keep that in mind. So if we're going to write the equation for a tangent line here, we're going to start out just like we did in the last problem. We'll find out our point and our slope and plug them in correctly. Well, let's find the slope first. So if we want g prime here, g prime is going to be e to the f of x times the derivative of f of x. E is its own derivative times the derivative of the argument. And we want g prime at 1. So if I fill in my blanks properly. E to the f of 1, we don't have a picture of f, but they told us in the reading part that f of 1 is what? 2, isn't it? So we'd have e squared here. And f prime at 1, the derivative at 1, we can see that's the point they have, that's negative 4. So ultimately we get negative 4 e squared. Questions on finding the derivative at 1? Alright, then writing the equation here. We got 2/3 of it done. We know the x coordinate in question. We know the slope here. And we also know the y coordinate is going to be the whatever g of 1 is. Okay. So we're writing an equation for g here at x equals 1. So what is g of 1? It's e to the f of 1. And what did we say f of 1 is? F of 1 is 2, so just e squared. So that would be our e squared. Again, no good reason to change that to any other form than that. Just leave it as such. 1 point for finding the derivative. On the derivative of g, you get a point. Finding g of 1 and g prime at 1. So if you got basically these two right here were worth a point together. You found the derivative by plugging in a 1. You found the y value by plugging in 1. And then 1 more point for writing the equation correctly. Any questions on that one? Alright, well, let's see what we got here on for part B. It says for negative 1.2 to 3.2, find all values of x at which g has a local maximum and justify it. So we know that we know already that g prime, which is something we're going to need, is e to the f of x, f prime of x. Alright, and we want to know essentially when is the derivative of this equal to 0. We know there's not going to be any non-existent points because they told us it's twice differentiable, so the derivative's always going to exist here. What do we know about this in terms of equaling 0? Can e to the f of x ever equal 0? Nope. So if that can't equal 0, then zero product property would mean only when f prime equals 0. Be our candidates. So f prime is 0 at negative 1 and 3. Those would be our two candidates for the derivative equals 0 of f. And if we test, negative 1, left of negative 1, the value of f prime is positive. Negative, all the way over to 3. Negative, not positive. And then positive after 3. So bottom line here though says which values of x does g have a local maximum? Well, the maximum would be right here, wouldn't it? Negative 1. Positive on the left, negative on the right. And again, the justify part of your justification could be your first derivative test. And again, are we going to get any points if we don't label this as f prime? Nope. Okay. Gotta label that, make sure you know what you're putting those into. Alright, and bottom line is, how do we know this is a maximum? Because f prime changes from positive to negative. One thing that we hopefully know this already by now, but I'll mention it anyway. One thing to be careful with on something like this is when we got these pluses and minuses, make sure that you say that correctly. If you say f prime changes from increasing to decreasing, would that necessarily be a fact? No. Okay. These are the values of f prime, so don't say increasing and decreasing. Could we say f changes from increasing to decreasing? That would be reasonable, but not f prime. Alright, so let's take a look at part C. Alrighty, on part C it says the second derivative of g is given by following: g double prime, it's e to the f of x, and then f prime of x all squared, plus f double prime of x. I guess that's it. Alright, and bottom line here is they ask us is g prime, or g double prime that is, of -1, is it positive, negative, or 0? And we're going to justify our answer here. So is it positive, negative, or 0 at when we got g of -1? So we fill in our blanks. See if we can decide. All right, let's start with we'll start with this one right here, because we know the derivative of f of -1 is what? F's derivative at -1 is 0, straight from our picture. So that part's 0. What about f double prime at -1? Remember what's going on at f prime? If you look at your picture, this is a picture of f prime, right? F double prime would be its derivative. Okay, what's happening at -1? Are we increasing or decreasing? We're decreasing. The second derivative would be negative, wouldn't it? So we're going 0 plus a negative. So we have a negative inside our parentheses here. And then finally, what about e to the f of -1? And we said it earlier, what do we know about e in general? If we raise e to a power, it's always going to be what? It's always going to be positive, doesn't matter what power it is. So if we have a positive out here times a negative inside, our answer is going to be ultimately what? It's going to be negative. Alright. I don't think I gave you the point breakdown for the last one, did I? In the last one, your points were 1 for the answer and 1 for the justification, essentially. So showing that it was a maximum and finding the maximum being -1, 2 points. This was worth 2 points also, 1 for getting the answer to be negative, and 1 for showing why. Yep. Yeah, I don't know, they put a little sentence in here, but ultimately we've shown it. I don't know if you might want to write. I guess the only thing that's not 100% clear would be the why this is negative. And you could say that the f prime is decreasing at -1. Maybe put a sentence like that in there just in case. So. Okay. Alright, and last 2 points are from part D. So let's take a look. It says on this one, it says find the average rate of change of g prime, the derivative of g, over the interval 0 to 3. So we want the average rate of change of g prime. So remember, if we have, just in general, if we have some function, let's say it looks like that, and we want to say, what's the average rate of change? Okay. Remember, the average rate of change is just the slope between endpoints. Now, remember, it didn't say the average value of g prime, it said the average rate of change of g prime. Okay. So if we're looking for the average rate of change of g prime, all we're doing is looking for the slope between the endpoints, okay, on g prime. Okay. So this being our g prime function here. And so ultimately, the x values in question are 1 and 3. Okay. So we need 1, then g prime at 1, 3, and g prime at 3. And that right there is going to give us our answer. Now we just need to figure out what g prime at 3 are and g prime at 1. So remember, g prime, we said earlier, was e to the f of x, prime x. And if we want to find the answer to this at 1, we'd have e squared and -4. We'd already calculated that one earlier, didn't we? So this would now be 1 -4 e squared. That's our first point. Alright, and then if I wanted at 3 this time, we got g prime at 3, we'd have e to the f of 3, f prime at 3. Well, what do we know about f prime at 3? F prime at 3 is 0, so that one's just 0. So 3, 0 would be our other point. So the average rate of change then would be 0 minus -4 e squared all over 3 minus 1. Give us 2 e squared over 2. Would be ultimately, 4 e squared, sorry. 4 e squared over 2, which would ultimately be 2 e squared. Alright. Okay, point breakdown. If you recognize that you needed to find a slope here, point, and final point was for the answer, 2e squared. Questions so far? Okay then, let's see if we can come up with some answers for the next part here, number 6. They give us a Taylor series for, they don't tell us what the function's for, it's just for f here. So this is some power series of f, and it says in part A, find the interval of convergence of the power series of f and justify your answer. If you look at the series given, what's the one thing that you want to note right away is that it's geometric. We're just multiplying by x plus 1 times x plus 1 times x plus 1 to get the next terms, and so on. Okay. Alright. And knowing that it's geometric, you can also see in the summation when they give us the fact that n 0 to infinity x plus 1 to the n, okay, it's also, not to the 2, but to the n, it's also in a form of being geometric also, where geometric are always in the form a times r to the n, some sort. And ultimately we know that this is going to converge when we know that that is less than 1. So if we do our typical work that we've done in the past, and we subtract 1 from both sides, we get -2 to 0. Alright, and the other thing we got to consider is the endpoints. Alright. So what about the endpoints? If I were to put a -2 in there, and I put a -2 right here, I got -2 plus 1, that's -1. If I did -1 to the n, what's going to happen with that series? Converge or diverge? Ultimately, the terms themselves are, keep in mind it's alternating, right? This is going to be -1, positive 1, -1, positive 1, -1, positive 1. And all the while, the terms themselves, the number parts, is just going to be 1, 1, 1, 1, 1. Does that go to 0? So this is not going to converge. If you think about it, if we were to make a list of these, I'd have -1 plus 1 plus -1 plus 1 plus -1, so on. And ultimately, the answer is just going to oscillate between 1 and 0, and It's never going to converge to any value, is it? So therefore this one would diverge. And if I put a 0 in there, I'd get 1 to the end, and what's going to happen if I go 1 plus 1 plus 1 plus 1 plus 1? It's going to grow infinitely, and therefore that's going to diverge also. So therefore the endpoints are, neither one of them are going to be convergent, so that would be our interval. Alright, and I guess our point breakdown here, got 1 point for the getting the right interval, 1 point for the way you got it, I guess. Yeah, essentially all that would be 3 total. Alright, then the next part, power series above is a Taylor series for f about x equals -1, and we want to find the sum of the series for f. So remember, bottom line here is if we're going to find the sum of any series, really the only time we can find the sum of any series is if it's geometric. Okay. And if it's geometric, then we know that a is equal to, or we know that the sum is equal to a over 1 minus r. So what's our a here? 1. And our r value is x plus 1. So if we ultimately, if we do the math on this, we're going to get 1 minus x minus 1. The 1s will cancel out. We'll get 1 over negative x. So ultimately our sum would be that then. We had some homework problems like that, a few where we had that geometric series, that if we want to find the sum of it, treat it just like any other geometric series. We find the first term in the common ratio, use our formula, simplify. And ultimately, it's 1 point for finding the sum. Okay, next part. We got, they tell us that we have a function g that's defined by an integral. And with that function g, we are asked to find the value of g of -1/2 if it exists, or explain why it can't be determined. Alright, and so if we're going to find g of that particular value, I already have the work written on here, so we'll go through it here together. We got -1 to -1/2, of course, because we're finding, we need to put that in for x. And then once we put that in for x, then we can try to evaluate that. Well, ultimately, the f function, okay, we just, excuse me, we just said in our previous work that that f of x, if you will, okay, which is ultimately the sum, which is that sequence, is defined by -1 over x. Okay, so that is our f of x, and so therefore if we have -1 over x as our integrand, and we anti-differentiate, we'll get our negative natural log x, so the value of x on -1/2 to 1. And here's a point where people would probably lose points, because if you take the antiderivative of that and you don't put the absolute value in there, what's going to happen when we try to put in -1/2 and -1? You do the natural log of -1/2 and -1? Nope. So bottom line is, people might say that you can't. Remember, one of the options they asked you in the question was that explain why you can't. Okay. But we know that you can, because we know that there needs to be an absolute value on that. So if we put in 1/2 and 1 in there, we're going to wind up with ln 1/2 minus ln 1 in the parentheses, and that ultimately equals ln 1/2, because ln 1 is 0. And then we could leave it like that. That would be acceptable. They give the answer as equals positive ln 2, because ultimately if we put the negative on top of the 1/2 as a power, 1/2 to the -1 is really just 2. Remember, if we have a 1/2 to the -1, that's the same as the flip to the positive power. Equals, yep. There we go. If you had this as the answer, they're not going to take points off of that. So that would have been okay to just leave it like that too. Alright. Questions on any of the parts of that one? Okay, point breakdown on that one. That was worth 2 points. 1 for finding the antiderivative, and 1 for finding the value. Well, there was the negative natural log of a half, or ln2. Okay.
Why did you use the sum for the integral?
Well, ultimately, remember in the beginning of the problem, if we look at the given information here, remember they gave us the fact that f of x, okay, that f is defined by this power series. Okay, so this is ultimately x. Okay, and keep in mind that f is this, which is the sum of all these. Okay, in part B, what did we find? We found the sum of all those to be what? Okay, the sum of all those was the negative 1 over x. Okay. So remember, we found that sum. Okay. So we said in the beginning, they told us in the beginning that this was equal to this, right? And we know that this is actually equal to this. So in turn, what does that tell us about f of x? F of x is negative 1 over x. Questions? Anything else? Okay, let's take a look at the next part here. They defined in the next part that this new f function, or h function, is defined as f of x squared minus 1. And tells us that find the first 3 non-zero terms and the general term of the Taylor series for h about x equals 0, and then find the value of h of 1/2. Alright, so 2 parts to that, obviously. We got to, first of all, take our h, which is defined to be f of x squared minus 1, and we'll need to manipulate the series that we have, okay, for f, because again we're finding the first 3 terms. So going back to that original that we were given, okay, our f of x, remember, was this. This was our original f of x. Okay? And if we're going to, in our f, replace x with x squared minus 1, then we need to do the same thing in our series. So if we replace those with x squared minus 1, so all those x's, we ultimately have 1 still, and then x squared minus 1 plus 1, and then x squared minus 1 plus 1 all squared, and so on. And with that, if we simplify, we wind up with, in the first one, the 1's just cancel out, we get x squared. The second one, the 1's cancel out, we get x squared squared. Okay. So there's your first 3 terms, 1 plus x squared plus x. And then the general term, and ultimately because they're all even power, so pretty easy to write the general term for this one. We just got x to the 2n is going to be our general. Okay. All right. Questions so far? All right. And in the last part, I should think about this. If I know that h of x is defined to be that, okay, remember we want h of 1/2. The only thing we know about h is that it's equal to f of x squared minus 1. So if I want h of 1/2, wouldn't that be the same as f of negative 3/4? Remember, if I put a half in here, I get quarter. Quarter minus 1 is what? Negative 3/4. Remember, I don't have an equation for h, okay, but I do know that it's related to f of x squared minus 1. So if I do that, if I want f of negative 3/4, and same reason, Jake just asked me a minute ago, what about why do we use negative 1 over x as f of x? Because it is f of x. So what are we going to do with that negative 3/4? We're going to put it into negative 1 over x. That's how we get our 4/3 there. Alright, if you got the first 3 terms, you got a point for that. The general term was worth another point. And the answer for the last part, 4/3, is another point. Questions so far?